A short answer second answer की 3 मार्काची असतात. फर्स्ट क्वेश्चन एक्सप्लेन द कन्स्ट्रक्शन अँड वर्किंग ऑफ मूविंग कॉईल गॅल्व्हॅनोमीटर. हॅलो फ्रेंड्स, कशा आहात? आज आपण महाराष्ट्र शासनाने शालेय शिक्षण व क्रीडा विभागाने 2023 मध्ये क्वेश्चन बँक पाठवली होती फिजिक्स या विषयाची. त्याची आज आपण आन्सर की बघणार आहोत. आज आपण मॅग्नेटिक फील्ड ड्यू टू इलेक्ट्रिक करंट हा चॅप्टर चालू केलेला आहे. चला तर मग ते क्वेश्चन्स बघूयात. ये शॉर्ट आन्सर सेकंड 9 आहेत. याची आन्सर आपण पुढील प्रमाणे PDF स्वरूपात पाहूयात. ए शॉर्ट आन्सर सेकंडची आन्सर की 3 मार्काची असतात. फर्स्ट क्वेश्चन एक्सप्लेन द कन्स्ट्रक्शन अँड वर्किंग ऑफ मूविंग कॉईल गॅल्व्हॅनोमीटर. Answer construction in MCG consists of a coil of several turns mounted into brackets suspended or pivoted in such a way that it can freely rotate about a fixed axis in a radial uniform magnetic field. Second, a soft iron cylindrical core makes the field radical and strong. Moving coil galvanometer diagram आहे. Mirror, upper suspended iron core, moving coil, former lower suspension, south and north pole. Working. First, the coil rotates due to a torque acting on it. Is current flow through it. A torque acting on current carrying coil is tau is equal to NIAB sin theta. Here theta is 90 degree as field is radical. Therefore, tau is equal to NIAB, where A is the area of the coil, B is the strength of the magnetic field, N is the number of turns of the coil, and I is the current in the coil. Second, this torque is counterbalanced by a torque due to a spring fitted at the bottom so that fix the steady turn current I is the coil produce a steady angular deflection phi. Therefore, second, large the current is large. Is the deflection of the larger is torque due to the spring. If the deflection is phi, the restoring torque due to spring is equal to k phi, where k is the torsional constant of the spring. Thus the k phi and AB and the deflection phi is equal to into bracket NAB divided by k into I. This means the deflection phi is proportional to current and that I is equal to, that is phi is directly proportional to I. Question number second, explain the Biot-Savart's law. Answer. First, consider an arbitrary shaped wire carrying a current I. Second, let's dl be the length of element along the wire. The current in these elements is in direction of the length vector dl bar, which produce differential magnetic field. dB bar is directed into the plane of paper as shown in figure below. Current carrying wire arbitrary shape diagram आहे. Angle theta आहे, ideal and dB bar आहे, P direction ideal आणि I. Third, consider a point P at a distance r from the element dl. Net magnetic field at the point P can be obtained by the integrating, that is the summing of a magnetic field dB bar from this length element. Fourth, experimentally the magnetic field dB produced by a current I in the length element dl bar is dB is equal to mu 0 divided by 4 pi into IDL into sin theta divided by r square. Equation first, where Theta is the angle between the direction of dl bar and r bar. Mu0 is the permeability of this free space is equal to 4 pi into 10 raised to minus 70 m as a approximately 1.26 into 10 raised to minus 60 ma. 5. The direction of dB bar is directed by the across product dl bar into r bar. Vectorially, dB bar is equal to mu0 divided by 4 pi into ideal bar into r bar divided by r cube. Equation second. Equation first and equation second are known as the Biot-Savart law. Question number third, numerical. A rectangular coil of 10 turns each of area 0.05 meter square suspended freely in uniform magnetic field of induction 0.01 T. A current of 13 mu is passed through it. First, what is the magnetic moment of the coil? Second, what is the maximum torque experienced by the coil? Solution. Given n is equal to 10, a is equal to 0.05 meter square, I is equal to 13 mu is equal to 30 into 10 raised to minus 6 a. B is equal to 0.01 t. To find first magnetic moment m of coil, second maximum torque experienced tau max. Formula m is equal to nia. Second, tau max is equal to nia into b is equal to mb. From calculation from formula, first m is equal to 10 into 30 into 10 raised to minus 6 into 0.05 is equal to 50 into 10 raised to minus 6 am square is equal to 15 mu am square. From formula second, tau max is equal to 50 into 10 raised to minus 6 into 0.01 is equal to 50 into 10 raised to minus 8 is equal to 1.5 into 10 raised to minus 7 nm. Answer. First, the magnetic moment of a coil is 15 mu am square. Second, maximum torque experienced by a coil is 1.5 into 10 raised to minus 7 nm. Question number 4. Using Ampere's law, derive an expression for the magnetic induction inside an ideal solenoid carrying a steady current. Answer. Consider an ideal solenoid as shown in figure below. Ampere's law applied to part of a long ideal solenoid. Ampere's loop A B bar D bar C. डायग्राम आहे. Second, the dots show that the current is coming out of the plane of the paper, and the crosses show that the current is going into the plane of the paper, both the coil square a cross section wire. Third, for the application of the Ampere's law, an Ampere loop is drawn as shown in figure and a box. Fourth, using Ampere's law, not integrated b bar into dl bar is equal to mu0 into I over rectangular loop for a b c d. The above integral takes from the integration a to b bar into dl bar plus integration b to c b bar into dl bar plus integration c to d b bar into dl bar plus integration d to a b bar into dl bar is equal to mu0 into I, where I is the net current encircled by the loop. Therefore, bl plus 0 plus 0 plus 0 is equal to mu0 I. Equation first. Here the second and fourth integrals are 0 becomes b bar and dl bar are perpendicular to each other. The third integral is 0 becomes outside the solenoid b is equal to 0. 5. If the number of turns in and per unit length of the solenoid and the current flowing through the wire is I, the net current coming out the plane of the paper is I is equal to NLI. Using equation first, BL is equal to mu 0 and Li. Therefore, B is equal to mu 0 Ni. Equation second. Equation second is required expression. Question number 5. Derive an expression for a net torque on the rectangular current carrying a loop placed in uniform magnetic field with it is rotational and axis perpendicular to the field. Answer. First, consider rectangular loop ABCD placed in uniform magnetic field B bar such that the side AB and CD are perpendicular to magnetic field B bar, but the side BC and DA are not as shown in figure A below. Figure loop ABCD placed in uniform F1, F3, F4, L2 F diagram आहे. Second, the force F4 bar on side 4BC will be F4 bar is equal to I into L2B sin theta into bracket 90 degree minus theta. Third, the force F2 on side 2DA will be equal to and opposite to F4 bar and both act along the same line. Thus, F2 bar and F4 will be cancel out each other. For the magnitude of the force F1 bar and F3 bar on side 1, CD and 3AB will be IL1B sin 90 degree, that is ideal B. These two forces do not act along the same line and hence they produce a net torque. 5. This torque result into rotation of the loop or so that the loop is perpendicular to the direction of B bar the magnetic field. Diagram आहे. Figure B आहे side views of the loop ABCD at an angle theta. Six. Now the moment arms is 1/2 into bracket L2 into sin theta above the central axis of the loop. Hence the torque tau due to force F1 bar and F3 bar will be tau into bracket I L1B 1/2 L2 sin theta into bracket plus into bracket I L1B 1/2 L2 sin theta bracket complete is equal to IL1 and L2B sin theta. 7. The current carrying loop is made up of multiple turns and in the form of a flat coil. The total torque will be tau dash is equal to n tau is equal to ni L1 L2 B sin theta. Tau dash is equal to into bracket n a into bracket complete B sin theta, where A is the area enclosed by the coil L1 and L2. This is the required expression. Question number 6. A circular loop of radius 9.7 cm carry a current 2.3 ampere. Obtain the magnitude of the magnetic field at the center of the loop. Second, at the distance of 9.7 cm from the center of the loop, but on the axis. Give solution. Given r is equal to 9.7 cm is equal to 9.7 into 10 raised to minus 2 meter. I is equal to 2.3a. Z is equal to 9.7 centimeter is equal to 9.7 into 10 raised to minus 2 meter. To find magnetic field, I is equal to at the center of the loop. Second, on the axis at the distance. From formula I, BC is equal to mu 0 I divided by 2R. Second, BA is equal to mu 0 I into IR square divided by 2 into bracket Z square plus R square into bracket 3 by 2. Calculation from formula I. First, BC is equal to 4 pi into 10 raised to minus 7 into 2.3 divided by 2 into 9.7 into 10 raised to minus 2 is equal to 2 into 3.4142 into 2.3 divided by 9.7 into 10 raised to minus 7 plus 2 is equal to anti-log log 2 plus log 3.142 into 42 plus log 2.3 minus log 9.7 into 10 raised to minus 5. Anti-log into bracket 0.3010 plus 0.4972 plus 0.3617 minus 0.9868 into 10 raised to minus 5. Anti-log into bracket 0.1731 into 10 raised to minus 5 is equal to 1.489 into 10 raised to minus 5, approximately 1.49 into 10 raised to 5t is equal to 14.9 mu t. From formula second, BA is equal to 4 pi into 10 raised to minus 7 into 2.3 into bracket 9.7 into 10 raised to minus 2 in whole square and divided by 2 into bracket 9.7 into 10 raised to minus 2 whole square plus 9.7 into 10 raised to minus 2 whole square into bracket whole square 3 by 2 is equal to 4 pi into 10 raised to minus 7 into 2.3 into bracket 9.7 into 10 raised to minus 2 in whole square divided by 2 into 3 by 2 into bracket 9.7 into 10 raised to minus 2 raised to in whole cube is equal to pi into 10 raised to minus 7 into 2.3 divided by 1 2 raised to 1 half into bracket 9.7 into 10 raised to minus 2 is equal to 5.268 into 10 raised to minus 8t is equal to 5.268 mu t. Answer. First, magnetic field at the center 14.9 mu t. Second, magnetic field on the axis of distance of 9.7 centimeter of the center is 5.28268 mu t. Question number 7. The magnetic field at the center of a circular loop of radius 12.3 centimeter is 6.4 into 10 raised to minus 60. What will the magnetic moment of the loop? Solution. Given B is equal to 6.4 into 10 raised to minus 60. R is equal to 12.3 centimeter is equal to 12.3 into 10 raised to minus 2 meter. To find magnetic moment of M, formula B is equal to mu 0 into IR square divided by 2 into bracket Z square plus R square into bracket 3 by 2. For calculation from formula, B is equal to mu 0 into I pi R square divided by 2 pi into bracket Z square plus R square into bracket 3 by 2 is equal to mu 0 into M divided by 2 pi into bracket Z square plus R square into bracket 3 by 2. Therefore, since M is equal to I into bracket pi R square bracket complete. B is equal to mu 0 M into divided by 2 pi R square is therefore Z is equal to 0. Therefore, M is equal to B into 2 pi R square cube divided by mu 0 is equal to 6.4 into 10 raised to minus 6 into 2 into 5 pi into bracket 12.3 into 10 raised to minus 2 in whole cube divided by 4 pi into 10 raised to minus 7 is equal to 3.2 into 10 raised to minus 6 plus 7 minus 6 into 10 raised to minus 3 whole square is equal to anti-log in a bracket log 3.2 plus 3 into log 12.3 into 10 raised to minus 5 and T log into bracket 0.5051 plus 3.2697 into 10 raised to minus 5 and T log 3.7748 into 10 raised to minus 5 is equal to 5.954 into 10 raised to 3 into 10 raised to minus 5 is equal to 5.954 into 10 raised to minus 2 am square. Answer: magnetic moment of the loop is 5.954 into 10 raised to minus 2 am square. Question number 4. State under what condition will a charged particle moving through a uniform magnetic field travel in first a straight line, second a circular path, third a helical path. The particle travel undivided through a magnetic field B bar. It is velocity V bar is parallel anti-parallel to B bar. In this case of the magnetic force of the charge is 0. Second, a charged particle travel in a circular path within the magnetic field B bar if it is the velocity V bar is perpendicular to B bar. Third, a charged particles travel in the helical path through a magnetic field B bar if its velocity V bar is inclined at angle theta to B bar 0 greater than theta is 90 degree. In this case of the component of V bar parallel to B bar is affected by the V bar magnetic field. The radius and pitch of the helix determined respectively by the perpendicular and parallel component of V. इथे आपले सर्व शॉर्ट आन्सर सेकंड्स आपल्याला आहेत. व्हिडिओ आवडला असेल तर लाईक करा, शेअर करा, सबस्क्राईब करा आणि बेल आयकॉन दाबायला विसरू नका, कारण नवीन अपडेट आपल्या चॅनलवरती तुम्हाला मिळत राहतील. धन्यवाद.